Hi, everyone. My name is Dan Ferrante. I'm the Director of Platform and Data Engineering at Digital Turbine. Today, I'm going to be talking to you about Delta, Lakehouse to scale, and a proof of concept that myself and my team went through in order to work with the new Delta technology and Databricks. So I want to talk to you a little bit about the agenda that I have today, give you an overview of what our company does, what Digital Turbine does, who we are, what we do, and where we've been in terms of data architecture. Talk a little bit about the Spark and Data Lake implementation that we've undergone, where we are with that, and then finally where we're moving in terms of or where we're going in terms of the different projects that we're working on. So just to give you a little bit of heads up, at Digital Turbine, we provide an ecosystem for delivering apps to end users, mobile devices, and insights to advertisers, carriers, and OEMs. So we simplify the app delivery process by maintaining campaigns, yield management, and extensive reporting to our customers. We own the platform enabling end users to select the install the applications they want in a first-time mobile experience. And Digital Turbine delivers the right app to the right user at the right time. So to talk a little bit about where we've been in terms of architecture, this image kind of says it all. It's basically a maze showing the variety of different services and systems that we've used in the past, from microservices to Redshift, Spark, S3, Storm, and Kafka. So basically, we have semi-structured data that's stored in Redshift. So we're storing raw data in Redshift broken down by partners for 2 years. And the data growth, along with requirements for more data faster, has slowed our Redshift cluster over time. But we've had to scale up several times in order to reduce the burden. So this is difficult to maintain architecture. You're struggling to maintain and manage an architecture that contained mostly self-managed clusters. Apache Storm, which you see up here, was used, and we've also used legacy versions of Kafka. So we're trying to, in the process of upgrading from earlier versions to later versions and having to manage all of that. So the goal is to really standardize on a set of technologies and thrive, and not just survive. So with also we've had problems with batch ETLs with no real time. So we're looking to deliver real time data, as it was not possible in the past with our legacy event mechanism. The Apache Kafka and Storm support we did have was outdated and in need of updating. So what you see here are the sources and sinks of our data. So we have what we call legacy mobile events that are feeding into our Redshift cluster. We also have unified mobile events, and unified mobile events are the next generation logging events that are sourced directly from our Digital Turbine mobile platform. We also have a campaign events pipeline. So that's a subset of revenue impacting events, such as app install or app open mobile events. And finally, to talk about the stores that we have, we're supporting Delta Lake, Redshift, and Datadog for monitoring dashboards. So this slide represents the event flow rates, the amount of events that are coming into our systems. So again, the circles represent essentially it's a pie graph showing the amount of data that's coming in, but those represent the sinks. Essentially, we have three different types here recognized. We have unified mobile events, which I talked about previously, represents around 74% of the events that are coming in. We also have the legacy mobile events, which again are the older events from our mobile clients, which represent about 23% or 40 million records per day. And finally, campaign events and SCDs are slowly changing dimensions, represent about 3% of the number of events that are coming into the system. So, to talk about the Delta Lake and Spark streaming objectives that we had when we were first looking into this proof of concept with Databricks and using Kafka and Delta, basically real time was one. So, using data directly from Kafka. So, we wanted to take advantage of the streaming data from Kafka for real time event observation and monitoring. And we're looking to retire real-time technologies such as Apache Storm, which are self-managed. We performed a proof of concept again with Databricks back in May, June 2020 to test Spark streaming and Delta Lake capabilities. We also want to use best practices. So offloading the semi-structured data from Redshift to S3, using Redshift as a primary repository only for data aggregations and data marts. And then S3 Delta becomes the repository for ad hoc queries and sources the aggregations in the data marts. Finally, talk about standardizing ETL technologies. So, we were trying to produce results that produce data that is accurate. So in other words, data fluctuates due to actions taken in the system. Fluctuations happen, but they need to be based on external events, not issues with the data itself. Precise data, so day over day and week over week, the data is consistent and provides a predictable pattern. And finally, reliable. So errors in the pipelines are identified quickly and require an incident and a quick response and are ACID compliant. This slide is talking about the design and architecture of our system. What we have here is in light green is future state, darker green is current and up to date, and the even darker shade, or I guess the darker blue is current and up to date, and the darker green is what's in progress right now and being worked on. So if you look at this, it shows your mobile user is using the mobile Ignite platform, the Ignite mobile platform from their mobile device. Automatically, that will log data and send data to an API from microservice that we call EventGate. This is our microservices framework. That then publishes out to Kafka. Databricks is then streaming that data from Kafka onto a regionalized set of streams. So we have regions for US West, South America, Europe, and Asia Pac. From there, the data is then pushed out to Datadog and also saved out into a Delta Lake. The Delta Lake is then being used to feed our Redshift cluster with aggregations, and Tableau is the backend reporting service that is actually pulling data from Atlas and producing reports. And here we're just talking a little bit more about design and architecture, but specifically talking about the design of the Delta layer. So we've created several tables here that are based on regions and based on actions that are included in our campaign events. So we have the unified mobile logging events, which are based on regions. The partitions are based on partner name, year, month, day, hour. We've generated our own identifiers that we call DTIDs in that case. Those can be tied to actions within the system, such as preloads, clicks, installs, and get ads requests. Those are partitioned off by year, month, day, and hour. And all of these are residing now within our data lake within S3 using Delta as the format. So here I want to talk about a little bit about the results from the proof of concept that we did. The system availability using Databricks and Delta was 99.99% available. We look when looking at over the past 2 months, we achieved that percentage. Basically 1 hour of downtime in 2 months on streams because of several factors. So Databricks is a managed manage the Spark availability and uptime. Spark structured streaming features are mature. We use micro batching and continuous triggers, and both hold up well in our high load environment. Um, Optimizations with the help of Databricks support. So looking at things like the number of partitions, so the number of min partitions, and then the max offsets per trigger. Finally, modularized code and job resiliency. So if a cluster fails, the job restarts itself. And then to talk about data time to market, our highest load partners handling around 300 to 500 events per second. We have multiple partners streaming data on an individual cluster, just to give an idea of scale. And Delta is loading every event, and we're running hourly queries against our Delta tables to verify the event counts are consistent. So with regards to communication and alerting the business, the following graph here illustrates our ability to track a particular client failure in real time with Spark Streaming and Datadog. So the red line on the far right indicates the moment that our mobile client was deployed with a fix, and our stream is in correlation with Datadog. It immediately detected the lower rate of failures. So this is just taking a look at Delta in use. We're currently streaming events from mobile devices to microservices to Kafka to Spark structured streaming, and then to Delta Lake and Datadog. We're delivering real-time KPI dashboards, ad hoc querying capability within notebooks, fast transformations using Spark, and then managed Spark clusters. So what this shows is an example of our ability to use a notebook to provide essentially real-time data, real-time information to our business and to our end users in order to show the number of events that are occurring within a certain time period. So some things that we have in the works, basically Redshift optimization. So our Redshift clusters currently contain raw data associated with the pipelines that we mentioned previously. So we really want to primarily use Redshift as a repository for corporate data marts with star schemas and migrate away from the raw data repository. Our business metrics and data wellness report, which is in the works. That report is intended to show the status of business KPIs in a straightforward and quickly understandable manner. So it's intended as a C-level set of reports to show business health. Thirdly, cost optimization and data quality reports, which are in the design phase. So understanding and controlling where costs are centered and detailing that information in executive level reports. Machine learning algorithms, so creating traffic and targeting algorithms to better anticipate how devices work in the real world, using the ability to access raw data from the Delta Lake. Then finally, data generation tools. So using Spark as a means for generating large-scale testing data for better simulating our mobile traffic through a staging environment. So here I'd just like to thank you guys for your time today. Please feel free to reach out to me at daniel.ferrante@digitalturbine.com. And if you're interested in working at Digital Turbine or learning more about our available positions, you can go to our career site, which I've listed here. So I just want to thank you for your time, and feel free to reach out to me at danielferrante@digitalturbine.com. If you're interested in learning more about available positions at Digital Turbine, you can seek out those positions at digitalturbine.com/careers. really want to thank you for your time today. And, again, your feedback's important feedback is important about this. So please don't forget to rate and review the sessions. Thank you. Thank you again.